Bismillahirrahmanirrahim. I am Professor Javed Iqbal Khokar, PhD Forensic Medicine Department, CMH Lahore Medical College. So this is my second video on the topic of firearms and its mechanics. Now today we'll discuss the ballistics. So this is, as I already explained in my introductory video for this channel, and this is for the understanding of the third year students and the young doctors. So do subscribe my channel and share and comment if you find any error and omission and discrepancy. Do let me know, comment in the comment box. I will be delighted to know if you share it with. So continuing with the today's topics about the firearms, today we'll discuss the ballistics. Ballistics are basically the knowledge of physical forces acting on the projectile or the missile. And these physical forces may be internal, within the chamber, called as the internal or the interior ballistics, and the external or exterior, the physical forces acting on the projectile when it leaves the barrel, when it travels in the other medium, air or any other material in which it travels. And the terminal ballistics or the wound ballistics. So this is the main important ballistics for which we are concerned, that we discuss the wound ballistics because we have to know the terminal ballistics causing the wounds. We have to know the kind of weapon, the type of injury. So it helps in understanding what wound ballistics is. So we'll discuss all these aspects one by one. So theoretically, when we say the ballistics, from interior ballistics to exterior ballistics, the bullet in the exterior ballistics theoretically should travel in straight line. But practically it has been seen that it assumes a curved pathway. It does not follow the straight line. It follows a curved pathway. And then here by striking at the terminal point where it causes the wound ballistics. So the travel of the bullet from internal to external ballistics is not in a straight line. It is a curved pathway. And this curved pathway is called the trajectory of a bullet. So about the chain of events within the chamber, that is the internal ballistics, what happens within the chamber? On the left, it is showing the cartridge case of both the pellets and the bullets. So this is the chain of events which is going on within the chamber. When the trigger is pulled, the firing pin strikes the primer cap. And in the primer cap, it's contained primer which ignites. And after it ignition, the anvil will be lifted up and the flame will enter into the main powder charge, which will burn, thereby increasing tremendous amount of temperature and will produce gases. And the chamber pressure will increase tremendously. And then this pressure will push the bullet or the shot, the pellets, which will move forward. The bullet or the pellet will exit from the weapon, and then the chamber pressure will fall to almost zero. So this is the chain of events which is happening within the chamber. This is the internal ballistics within the chamber when the firing pin, by pulling the trigger, strikes the primer cap, and this chain of events starts. This is a diagrammatic showing a graph that there is tremendous amount of pressure being generated, increased, and then it by later on falling down after the exit of the bullet. So this is the amount of energy produced in the chamber. You can see that amount of pressure which has been generated within the weapons. In revolvers, it is almost 4 tons. In pistols, it is 6 tons. In rifles, it is about 20 tons. And this will produce the velocity, the movement for the charge. So it can be seen that the revolvers will be having 600 to 900 feet per second speed of the bullet, where the pistols 1200 to 1400 feet per second, and the rifles, they are the high velocity weapon having 2000 to 3000 feet per second. So this, the chain of events, diagrammatically it is shown that the trigger is pulled, the firing pin strikes at the primer cap, the primer ignites, which will lead to ignition of the main powder charge, and the tremendous amount of energy will be released, which will push the bullet out of the barrel. So this is the base where the primer cap is, where the firing pin strikes. These are various diagrams showing the base where the primer cap is, where the firing pin strikes, the anvil will be lifted up, and the flash hole, from the flash hole, the flame will enter into the main cartridge case where the main gunpowder is, and it will be ignited, and which will cause tremendous amount of energy. Now the external ballistics or the exterior ballistics. That means when the bullet leaves the barrel, what are various physical forces which are acting upon it. So the external ballistics is the basically knowledge of forces or the physical forces which are acting on the projectile when it leaves the barrel till it reaches the target. So the forces originating within the weapon which will cause the bullet to move forward. So one positive movement will be the speed, the forward movement. That will be the rate of motion or the speed. And the other will be the direction of motion. So these are the positive forces which have been imparted to the bullet or the pellet by the weapon. And this this direction of the motion will further having a forward velocity and rotational velocity. As the rifled weapons are rifled and they give spin to the bullet. And with that spin, they rotate upon its own axis. So these are the forces which are acting, which are imparted by the weapon to the bullet. The forward velocity and rotational velocity. Whereas the negative forces which are in the medium, which are interfering with the speed, the air resistance and the gravity. The air resistance will try to reduce the speed forward velocity, whereas the gravity will pull bullet down. It will not allow the bullet to travel in forward straight line. So that's how the bullet assumes a curved pathway. This curved pathway is because of the pull of the gravity which pulls the bullet down. That is trajectory. So these are the forces which are originating from the weapon, the velocity, the rotational movement, and the speed of the bullet. So the muzzle velocity will be variable, different depending upon the type of the weapon, low velocity or high velocity, and the forward direction and rotational movement will be depending upon the type of rifling, how accurate it is. And these are some other movements that bullet, despite moving forward with the forward velocity and rotational velocity, it will be having other atypical movements like yaw. Yaw means that the tip of the bullet dips up and down. During the flight, the tip will be moving up and down. That is called as yaw. Then precession, that the bullet is revolving in its own axis. That is recession. And then nutation. So these are various atypical movements of the bullet. Despite forward velocity and rotational movement, the bullet will be showing yaw or precession or nutation. So the negative forces which are present within the medium are the air resistance and the gravity, and it will pull the bullet down, and the projectile will be following a curved pathway, and this curved pathway is called as trajectory of a bullet. So trajectory of a bullet is when the bullet leaves the barrel, its forward movement is interfered with by air resistance and gravity, and it assumes a curved pathway that is called as the trajectory of a bullet. So you can see that this picture showing that the bullet is hitting at a lower level than the actual target. And this is because of the pull of the gravity which pulls the bullet down. It does not allow the bullet to travel in straight line. It will hit at a lower level than the actual target. And this downward movement will depend upon the range. As the range will increase, the curved pathway will increase. So the amount of lowering of the bullet from the actual target will be depending upon the range. If you are close to the target, the reduction will be less. If you are far away than the target, then the reduction, that is the lowering level, will be more. So to overcome this curved pathway, a specific phenomena is done which is called zeroing. In this zeroing, with practice firing, repeated firing again and again, the angle of sight of the weapon is adjusted or raised such that it covers that trajectory, that curved pathway. That is called as zeroing. That you zero a weapon. You adjust the sight of angle that you cannot make the bullet to travel in a straight line. It will be traveling in same curved pathway, but by simply adjusting the sight of the angle on the weapon, you will cover that curved pathway and it will then hit the target, hit the bull. That is called as zeroing. That you make a weapon zero with repeated practice firing and keep on adjusting the angle of the sight such till it is accurate. That is called zeroing. Another ballistic coefficient is that how efficient a weapon is. This determines the efficiency of a bullet, how it overcomes the air resistance. And these air resistance, the previous which we discussed, that is to overcome the gravity, and this is to overcome the air resistance. Ballistic coefficient, how can we overcome this air resistance? This is by various techniques. That is, either you can change the shape of the bullet with the help of jacketing or with the help of rifling. When you change the shape, that is, instead of being a rounded tip, sharp conical tip, that will cause low resistance. And if you jacket it, then that is polishing, that they cover the lead coarse material with fine alloy, that is called jacketing. It will smoothen the surface, so will offer less resistance. Similarly, rifling is when you engrave the